Okay. Yeah. Yeah. Okay. Let's continue. Hi, everyone. Sorry, I wasn't around last week. I've had a nasty flu, as you can still hear from my voice, but probably I'm not contagious anymore. So, yeah. So let's continue. Before we continue with the rest of the material for today, we will have a quick look at AI and programming. Probably many of you have already tried this and might be already wondering what's the right way of doing this, what's the right way of using AI tools. And today we are hopefully going to have an idea after this part. So let's open use of AI notebook. So before I start, we would like to remind you that this is just to give you an idea of how you can use AI properly and to make you aware of the risks and also potentials of using such tools when programming. But by no means we are encouraging the use of AI tools for this course especially. So still you need to refer to the guidelines for the course, how you can use AI and large language models, like Dave said at the beginning of today's lecture as well. Yeah, so that's the goal of this part of lesson, to see how we can use effectively and also be aware of the risks and potentials of using AI for programming. So there are many ways of defining AI, and I know in computer science field there's a lot of controversy, what is AI, what is not, so it's a bit hard to try to define it, but maybe a very simple definition of AI or artificial intelligence is a computer or a computer program that tries to do what humans usually do. So it has some level of intelligence programmed into it. So using data, it can do what humans do well, usually. And so this is a concept that has been around for decades already, but what we have been seeing more recently is maybe these large language models, which became even more popular, more famous the last couple of years with products such as ChatGPT. So LLMs or large language models are just a subcategory of AI in general, and they're good at comprehending human languages. So as you probably have tried tools such as ChatGPT or other chatbots, you know that they can understand you quite well, and they answer you in quite fluent human language. So that's what they're good at. So for this demonstration, we are going to use ChatGPT, which is maybe one of the most popular LLM products nowadays. And we show you how you can make up an account. And as I said, you're not required to do this. You can just watch what I'm doing here and follow along, but you don't have to create an account if you don't want. Yeah, so signing up for ChatGPT, which is an OpenAI product, is fairly easy. Just like any other website that we are very familiar with, you can just sign up using your email or connect it with your Google account or Apple ID and so on. I'm not going to open ChatGPT now, but I've done this before and I'm going to just show you how things work. So this is the interface of ChatGPT, and a few other large language models have rather similar interfaces. And well, basically what you have here is a place where you can write a prompt. And we are going to talk about prompt a bit more during this part of the lesson. And that's very important, is the way how you communicate with the machine here, with the large language model, with the AI. So this is where you type in what you want and then you get a response here. So a prompt is a specific instruction, query, or input provided to a computer program, or AI in our case, to elicit a desired response or output. So this is your way of communicating with the program, and computers are logical. So if you want to get reasonable output from the AI model in this case, you have to be as clear as possible. So you have to be very specific, you have to provide enough context, and you have to avoid any kind of vagueness if you want to get reasonable output from your prompt. So this is a very simple example of a prompt you can write to ChatGPT in this case. So I have tried this before, and Yeah, so we will start with a simple one. Write a Python function that adds two numbers. So I just asked ChatGPT to create me a Python function, which we just learned about, to add up two numbers. So it just created me this is a small function that is called add underscore numbers. It takes two inputs, A and B. It just returns the sum of the two values as I had requested. So ChatGPT and similar tools usually come with memory. So during the same chat, and recently they asked me some upgrade, for example, to ChatGPT, so it has a memory that remembers your conversations over different discussions, different sessions. So it has some memory of what you're working with, what are the things that you're usually asking the tool about. So, for example, now it remembers that it has given me this function that adds up two numbers. So I can just build up on that previous prompt and ask ChatGPT to give me an example of using the output of this function in an F string, which we have used a lot in this work. So it just continued and gave me an example. So this is the function we already had, and it just showed me an example of two numbers, 5 and 3. It adds them up, and then it uses a function to sum them up, and then it creates me this formatted string, this F string, which prints out the output. And this is what it does. So if you're running this, you may not get the exact output as you can see here, and there are a number of reasons for that. I did this a while ago for this lesson, so there has probably been changes to the model. It's continuously training, so it's getting probably better and better. And also there are a number of factors like what is the context, what have you talked about in the same chat with ChatGPT or other tools. So based on the context, what model of the tool you're using, it might give you different answers. There is also a factor of randomness. So to make it more natural, it doesn't produce the same result every time. So there's a factor of randomness. So if you run the same prompt several times, you probably get a slightly different output. So what you might get now is not probably the same, exactly the same as what I have in my examples. So I continued and asked ChatGPT to add inline comments to the code, and it did it for me. It also added this doc string, it's like this block comment, which I hadn't asked for, but anyway, it's nice. But it also added nicely these inline comments to make my code a little bit more readable. So let's try another prompt. This is something I tried earlier. So I asked ChatGPT to write me a Python function that converts degrees Fahrenheit to Celsius, something that we have done a few times already today. And this is what it returned me. And this time it has included the doc string because it remembers I asked ChatGPT that, okay, I want inline comments. So it remembers that I like to have my code commented. So that's why this new function already comes with this doc string, and it does the calculation for me. So this is very similar to what we have done before today. So we can just quickly test this function to save time on copying this piece of text. I'm going to provide a temperature as the input. So I will just put 77 Fahrenheit, and I want to convert it to Celsius. And I will store it in the variable temp. Let's see what we get as output. So let's remember to run this first. So the function is defined, and then if we run this, we get the output. So 77 degrees Fahrenheit is 25 degrees in Celsius. So the function seems to be working well. So one important thing, one mistake that very often people make when using such tools is that they are not clear enough with their prompts. So you have to provide enough context. So now I've been talking about temperature with ChatGPT. So if I ask ChatGPT to convert Kelvin to Newton, it will know probably that I'm talking about temperatures. But for this demonstration, I started a new chat, so there was no context. It didn't know what I'm talking about, what we are talking about temperatures. There was no context. So I just suddenly asked ChatGPT, make me a function to convert Kelvin to Newton. And what it just returned was a mistake that you might see very often when using such tools without being careful. So it just defined me a function that seems to work fine, like programmatically, it looks fine, but it just doesn't make any sense. It is called Kelvin to Newton, but what it is doing is basically this, the Newton law, which has nothing to do with the temperature unit that we wanted. So the output is just nonsense, so it doesn't mean anything, even though if you run it, you will get the output. So you have to be careful. Because I didn't say anything about temperature, so ChatGPT was confused with my prompt. So I can refine this and say, give me a function to convert temperature from Kelvin to Newton. Then it tries to do it a bit better. And this is the output I've gotten. But this looks better. But there is still something wrong with this. Can anyone notice what's the problem in this equation? So earlier today we saw this equation, but it is for converting temperature from Celsius to Newton, not from Kelvin. So it's just using the wrong equation to do the conversion. It's easy to just miss this if you just make a prompt to ChatGPT. This is the output. You run the code, you get the output. You don't get any errors, but the equation itself is wrong. So for converting Kelvin to Newton, you need to bring Kelvin first to Celsius, and then this equation would work. So even though it's programmatically correct, the calculation itself is wrong. So another thing is that, like I said a few times, when you are making a prompt to ChatGPT, you need to be specific. So this function is, I'm going to just use this function, although the calculation is not correct, but the function itself works. So I'm just going to use it and test something. So I have a list of temperatures that are stored as a list. So let's just put some random numbers. So now I'm going to use this function that ChatGPT created me, and I just copy this name from here. To convert the temperatures stored in this list to Newton. So as input, I just provide this name of the list. If I run this, I get an error about the type. And the reason is that the function that was created for me earlier is made to work with numbers, not a list. Now that I provided a list as the input of the function, it's giving me an error that there is a problem with the type. So this is a reminder to us that, okay, if you are using such tools, you have to be very specific with the prompt. So if I wanted the function to work with a list, I should have specifically said to ChatGPT that, okay, the input of my function will be a list. Make me a function that works fine with the list. So that was the problem. So I made a prompt again, and I asked ChatGPT to give me a Python function to convert a list of temperatures in degrees Kelvin to Newton and print out the result. So the equation is wrong, so ChatGPT doesn't know that the equation was wrong. But this time it made modifications to the response, so it's creating two functions, and then it is made to work with lists now. So if I try this again now, with my list of temperatures, which I guess I have called temps, it should work out this time. And I will just I didn't run this cell, let's run this first. Now we get the output. So I didn't add a print because the function that ChatGPT had made me already had a print. And you see, this is another example of a function that doesn't have any clear return. So it's just printing the output for us. So another thing that I asked ChatGPT to do for me was to create a function that classifies an input temperature to 5 classes. And this is the output that I got from ChatGPT, and it's interestingly wrong in a number of ways. Can you see what are the things that are wrong with this block of code? It is operational, so there is no syntax error. If you run it, you won't get any error, but it is off in a number of ways. So. Okay, so I go through them. Some of the things I see wrong with this piece of code. Like one of the things that is very strange, and you will spot it even more quickly when you now you just learned about functions, but when you start like using them in your exercises, you will see it more quickly. So now ChatGPT weirdly is defining two functions within each other without like it doesn't serve any purpose. It's defining a function here that doesn't do anything, and then under it there's another function defined. It doesn't cause any syntax error, but it's just random. It doesn't do anything. So that's one problem with this piece of code. So if you run it, it will work, but then whoever looks at your code knows that, okay, you have made a big mistake, or it's obvious that you have used ChatGPT without like checking the output. And another problem with this is that, well, I asked it to create 5 classes, but what happens here is that, okay, there are 5 classes, but then again, there is this else, which is returning hot. So in fact, what I get as output is 6 classes. So it's not exactly what I asked. So if my assignment, if my job was to create a function that classifies values into 5 classes, now I'm getting 6 as output. So it's not exactly what I asked for. So that's another problem. Another problem is that we didn't give enough context to the ChatGPT. So it doesn't know what this classification is for. Is it like cold or hot for like as how we perceive temperature? Is it cold for us, or is it for a car, for a machine that is operating at higher temperatures? Because this classification for us doesn't make sense. If temperature is between 40 to 60 degrees Celsius, it is moderate. It's not moderate for us. It might be for a car running or a machine. So we haven't given enough context. It's just made some assumption, and the classification may not make so much sense. So again, a reminder that if you use such tools, you should provide enough context so it knows what you want the classification for. So there are a few examples how you can here modify this and improve this. I skip them for now, but you can go through them later. But if I want to improve this, of course, I will modify the classification, put something that would make sense, depending on our case, what we want the classification for, and I would get rid of this other definition. So it would be enough to just use this piece of code. So the other definition is not needed. So if you end up using such tools more in your work, you should remember a number of things. One of the things is the privacy matters. Of course, depending on what products you're using, what are their terms of use, this might work differently. But just be aware of what you share with such tools, because it's a little bit of a black box what they do with your data. So do not share very personal things, and just remember like what you're sharing and whether you want to share that data, that piece of information with such tools. So privacy matters is very important if you're using such tools. And a few conclusions. So if you're using such, well, one thing, if you ask me, this may be a personal opinion, is it good to use ChatGPT or similar tools for programming? I would say that, well, I see it as a calculator. Using a calculator is not bad, but it depends on like who is using it. So if you're in elementary school just learning to learn mathematics, probably using a calculator is not the best idea. But if you're already good at math and you want to just make your job easier using the calculator, then why not? In our case, we're just learning to program, to write codes in Python. So if you just get too used to using such tools, probably it's not a good idea. But if you end up using this for your work, then just be careful with the prompts. So provide enough context. Try not to be vague, and if you have a very complex logic, they might have such tools might have a hard time understanding. So try to break it down into a more machine understandable statement. And then always test. So whatever output you get, you should not rely on it. So always test and just make sure that it does what you need. Yeah, so that was a brief overview of using such tools for programming. Do you have any questions, comments from this part? If not, we can move on to the next part of our lesson, which is using a script file. So I'm going to open this notebook, writing scripts. So what is a script? It's just, well, it's a list of commands that you provide to a computer. So you can think of it as a computer. So it's a piece of your code that you can store somewhere else. And it consists of a number of commands that you provide to the computer to do a certain number of tasks for you. So far the programs we have written, the codes we have written have been to do rather simple tasks. So the code was rather short. And also we have been using Jupyter Lab environment for our work, which is not always the case if you're doing your programming for other purposes. It works well for our course, but you may use you may not always be using Jupyter Lab for your programming. So things may not be as organized and nicely put like it is in Jupyter Lab, and you have these cells and everything. And when you're doing more serious programming, doing more sophisticated, more complicated tasks, your code usually becomes very long. So you just learn how to create different functions. So imagine if you're having a program that takes care of a very important task, very difficult task, you probably have to find a number of functions that do different things. So if you keep all those things in your one file, probably the file gets very long and hard to read. So that's one problem you might have. Another thing is that many of the functions you define, you might want to use in your other programs. So for example, now you learned how to convert temperatures from different units So this is something, if you work a lot with temperatures, this is something that you might need in many of your programs. So of course, one way is that you can just open one of your old files and just copy the piece of code you had there. But a better way of doing that is to use a script. So you have separate files that, for example, you define your functions, and then you can use these files. You can always import functions from those files. So this is the idea of a script and why we are trying to use it in this part of lesson. So what we usually do in order to store our code, those extra pieces of code that we will see, those scripts, we create a new Python file that has a suffix .py. So let's start doing that. In Jupyter Lab, you can just easily do it by going to File, New, and here you can create a new Python file. So this is a Python file. You can just write Python code there. So now we are going to use one of the functions that we have worked with already several times today, and it's a function that converts temperature from Celsius to Fahrenheit. So I'm not going to type this again. I will just copy this piece of code from here. You can do the same. And I will go back to this new .py file I just created, my script. I'm going to paste it here. And then remember to save the file. When you save the file, you are prompted to pick a name. So choose a name that makes sense. So the same thing we have learned about picking good names apply here. So if you're picking a name for your script, pick a name that would make sense, and then you can remember it later when trying to reuse this script. So I'm going to call this temp underscore converter. So this is now saved. I go back to our notebook, my notebook file. If you at some point decide to change the name of the file, of course you can just easily do it from here. You can just right click on the file. In our case, this is the temp converter, which I can already see. It appears as a Python file. You can just right click and rename the file easily. Just remember not to change the suffix of the file. We want to keep it as a Python file. Okay, now that the file is saved, so now we want to go and try this a bit later, but before that, let's try and add a few other functions to our file. So I will copy these codes from here. So the first one is a function that we already saw. It converts temperature from Kelvin to Celsius. And the second one is a function that converts temperatures from Kelvin to Fahrenheit. So again, I will copy this and paste it into my script file. Put a space in between to make it a bit more readable. And remember to save the file. If you don't save it, of course, it won't be read when you try to import it. Okay, so when you're trying to read the file, one important thing is that Python should be in the same directory as where you have the file. It should be correct for us, but to make sure that our Python is in the same directory, is looking at the same directory, we can use this IPython command. So probably it looks familiar for you, for those of you who have used terminal. And we also looked at it in the first two lectures, second lecture with Git. So we use just this ls to see a list of the files that exist in that folder. So I can see that these files exist in my folder. So it tells me that, okay, I'm in the right directory. So if I try to import this, and I see this tempconverter.py file I just created, so importing this should be okay now. So if your Python is looking at a different directory and you try to import the file, you will get an error that the file doesn't exist. But now we are in the right directory. So using this percentage sign, this is coming from IPython. So you can do different kinds of commands. So if, for example, you are in the wrong directory, you should not be now because we are probably on the same page with this. If you are in the wrong directory, you can just use cd to change directory, like we have done before. So you just put percentage sign and then cd, and then you put the path to the right directory. Then you change then the Python will look at a different location. So now in our case, we are in the right directory. We saw the temp converter already. If you want to confirm it again, I will put this. So we're in the right place. So now we try to import our function from the script. So this is how you do it. You have seen already maybe briefly examples of importing things, and we are going to look at it more later today and also in upcoming lessons. But this is how you do it. So from here you put the name of the file from which you want to import those functions. So in my case, I saved it as temp converter. You do not need to, you should not put the suffix, so do not put the .py extension here. The name of the file is enough. And from that file, I'm going to import a function called Celsius underscore 2 underscore bar. So this is one of the functions that I have previously saved to this file. So Celsius to Fahrenheit. So let's just run this. And you should not get any error. If you have an error, then it probably means you have a typo or you're in the wrong directory, so Python cannot find the file. Otherwise, the function should be imported successfully. So now let's see how it works. So now this function that I have defined in that separate script file should be accessible. So I'm going to try and do something and use that function for it. So let's start by printing something, and I'm going to use fstring here. So I want to get the freezing point of water in Fahrenheit. So let's just write a piece of text here, the freezing point of water. And here I'm going to put the value, which I can directly get from the function. So the function we imported is Celsius to Fahrenheit. You can type it again or just copy from up there. And I want to get it for freezing point of water, which is at 0. Yeah. And you got the output. So the freezing point of water in Fahrenheit is 32 degrees Fahrenheit. So as you see in this notebook file, we did not write the code for this conversion. So we just wrote it in a separate script file. We imported it. So it makes our code here a bit more concise. So we don't have to have everything in the same file. So there are other ways of importing functions from a script file and also modules. We will look at this a bit later today. So from the same file, so you can, if you have a file named my script, in our case it was called temp converter. So if you have multiple functions you want to import at the same time, you can just list them like here and put a comma in between. So if you wanted to import all these three columns, all these three functions at the same time, you could have just used from temp converter and then put the name of the function separated by a comma. There is another way of importing things. So we can import everything in our script. So import temp underscore converter. And we are going to give a short name for it. Later we will see that it's a useful thing, especially if you have a script files that have like long names or we have module names that are a bit long. But here I just give a short name to it, TC, short for temp converter. So let's run this. Then I'm going to just copy what I had written before and just make some modifications to save time. So this time, because I didn't explicitly import that one function, but I imported the script, and I've given my script a short name TC, so I can access that function from TC. So I just say from TC, like TC dot Celsius to Fahrenheit is the name of my function. So if I run this, I should get the same output again. And you can try this for different functions here as well. So let's try it for another function we have here, Kelvin to Celsius. So remember that you have given it the short name of TC, so you should access the function by putting the TC dot at the beginning, and then you put the value you want to convert. So from Kelvin, let's say from 300 degrees Kelvin, I want to convert to Celsius. You can put a string here. I didn't. I just want to print out the value. If you just run it, you will get. So the same thing applies. If you have many functions in the same file, the same thing would apply here. So this is an optional part of this, but it's good to go through it maybe in your own time. And it's a more complicated tool for calculating temperatures. So it takes multiple inputs and it calculates. So you can specify what is the unit from which you are converting, and then you will give the value, it will give you the output. The code is here, maybe you can look at it at your own time, but it's a bit longer. But the logic is the same. So we are using the functions that we have defined here to do the calculation. So one thing that Dave already mentioned briefly, and we are going to look at it a bit later, is this docstrings. When you're defining functions, it's a good practice. Like we have talked about how to comment things in your code to make them more readable, more usable for yourself in future, or if you're sharing it with other people later on. One useful thing that you can do with, you should do with functions is to define a docstring inside, and you can define this docstring by putting these 3 double quotes. So this will give you, well, if you look at the function, it gives you some, well, information about what the function is about. But also if you try to access the help of the function, if you just put the name of the function with help, and we are going to see that a bit later, then you will get this information printed out. So it is useful. But let's get back to that later. Do you have any questions about the scripts? Anything unclear here? If not, let's move on to the next part of our lesson. Which is loading modules. So let's open the next notebook file, module, let's name module. So let's go with that. So what are modules? You've probably heard the word from us a few times during this course. In the same concept, similar concept exists in different languages. In many languages, it is referred to as libraries. So for your work, you might import different libraries that give you different kinds of functionalities. So you do not always have to write everything yourself from the scratch. There are a lot of useful libraries written in different programming languages that allow you to do things a bit more quickly. In Python, both terms library and module are used, but maybe more module. So these are packages developed by other people, other programmers that are written for carrying out certain specific tasks. And if you need to perform that task, then probably you do not need to write the code again. You can just use that module to do the job. So it is basically the same as what we just did. There are a bunch of script files containing codes, functions, and different things that you can just import and use in your own program. In the example we just saw, we created our own script, we imported our functions from our own script. But in case of module, probably someone else, a team somewhere has developed the module and you're just using it. But the idea is the same. So yeah, so we saw an example of this already on the first lecture. Remember, if we wanted to do some more complicated mathematical operations, and they were not built in, there were no built-in functions readily available in Python for it, and we needed to import a library to do that. And for doing that, we imported the math function, and importing it is as simple as just writing import and the name of the module. So in this case, we are importing math function. Let's just run it. You don't get any output, but if you don't have any error, it means that the library was available and you imported it successfully. So what I'm going to do now is to use a function that is coming under that package, under that module that I just imported. So in this case, I'm just going to try out this square root function, sqrt, and I'm going to see what is the square root of 81. So what we are doing here is similar to what we did with the script. So there's a script where this function is being defined, and now we are just reusing that function. And for being able to do that, you need to first import the module that has the function, contains the function. There are some functions that we have seen already, and they are built-in functions of Python. For example, we have used countless times the print function to print out different text, different results of our work. So this is something that already comes with Python, so you do not need to import any library in order to reprint something. So let's just do it again. So yeah, so many simple, basic functions are already available in Python. Some of them that are a bit more complicated, more advanced, you need to import. But with depending on your Python installation, there are a number of modules coming with your package, with your installation. For example, math is one of the libraries that usually comes with the installation. But very often, if you need some specific module, you just need to install the library yourself. And then you can just import it and use it. So one thing that we already saw when we were working with our script is giving a short name or renaming a library, like in your work environment. So you can do the same thing here. If you want to import math and call it something shorter, you can just use import math and put as, and give it a short name. It can be anything you want. In this case, I'm just using M. So from now on in my code, I can call just in that code. So it doesn't rename the module itself. It's just in your session. When you're working, now when you import the library, you can call it M. So there are a number of reasons why you may want to do that. For math, it may not make so much sense, but there are some modules that have longer names, and you might need to call them many times during your code, and it gets a bit tiring to type it over and over again. For some of you who are continuing with the second part of this course, like with GIS, there's a library we work a lot with called Geo-Pandas, and it's a bit it's hard to type it over and over again. So very often it's imported as GPD. It doesn't matter what you call it, but it's in the standard. Most people using Geo-Pandas import it as GPD. It makes it a bit easier for you. It saves you a bit of time, so you don't have to type it. So in our case now, we imported math as M, so we don't need to type in, we shouldn't type in math anymore, because now its name is M. So from M, I can now access the function sqrt and calculate the sqrt of the square root of 49. And you get the output as 7. And if you check what is the type of M here, you will see that it's a module. So this is a module that you just imported and you renamed it to M. So there is a library there is a module that we will be working a lot from next week on. It's called Pandas. Very often this, like if you see scripts, programs using Pandas, very often they rename it as PD in their code, so it's a common standard, common practice. So you will see this a lot. Probably import Pandas as PD. We are not going to use Pandas now, but you will see this later on. So just be reasonable when giving a name. We have already talked about picking good names, whether it's a variable or it's a function, just the same thing applies here. If there is a good practice, for example, with Pandas, there's PD, or with GeoPandas, GPD. If there's a good practice, just stick to that practice. If there is no common practice, then just use some name that makes sense to you, and later when you look at your code, you would more easily remember what that short letter refers to. So this imports the whole library. So when you write import math, it imports the whole library to you and all the functions are accessible to you. Sometimes you want to import a single function from the library, and there are some pros and cons to that, but let's just start looking at it and see how it works. So from math, I will import just one function. So I don't need the whole library. I just want to use this square root function, which is called sqrt. So when you import a certain, like a specific function from your library, then you do not need to refer to the whole module name when you're trying to access that function. So now if I just use sqrt, and if I get the square root of 121, it works. So I didn't need to specify the name of the module. And this can be useful sometimes, but there's a risk with it, and that is that there can be a conflict. So if you import a function like a sqrt, and you have used the word, because this is not a reserved word in Python. If you have used the word sqrt to name your variable, to name some other function, there can be a conflict when you import it. So if you do that, you should be careful and make sure that there is no conflict with the names. Many big libraries come with many sub-modules that take care of different smaller tasks. It is useful sometimes to just import that sub-module. So if you're not going to use, if it's a heavy library and you're not going to use all of it, then it might be better to just import the sub-module that you will be using. This is something that we will get to later on when we start visualizing things. And we will start using a library called matplotlib. It has a sub-module called pyplot that gives us some extra functionalities that we will use later on. So if it is just the sub-module you use, you don't need to import the whole library. So this is how you would do it. So I say import from matplotlib, import the sub-module pyplot, and then you can give the short name for it. So PLT. So remember that this short name is now referring not to the whole library, but to that sub-module that you imported. So this is something we will get back to later on, but let's just try how this visualization works now that we imported this sub-module. Remember to run this first line to import it, and then we run this second line that will just quickly make a chart for us using this sub-module called pyplot, which we named shortly as PLT. So yeah, so we created a quick chart using this. So using module functions, let's just move on. So very often when you import a module, you're familiar with the module. They come with like documentations. You probably have done your research, you know what you can do with it. But from within your Python environment, if you want to know what kind of functions are available in the module that you just imported, there are ways of doing that. So you can just print their math, and math is the name of the library that is already available. Then you just get a list of the methods and functions and different things that come with the package. So you can have a quick look of, at how it works. If you're working in Jupyter Lab environment like we are doing now, when you write math dot, it already knows that, okay, you're looking for a function from within that library, from that module. So it starts suggesting you a number of functions that are available. So you will see this kind of drop-down list from which you can just double-click a function, then it just puts the text for you already, so you don't have to type it. This is also a handy thing. If you want to learn more about a function and how it works, if you want to see some documentation of the function, from within Python, you can just use help, and then you put the name of the function. In this case, this sinus function is coming with math. So I'm accessing it through this math library, and it gives me some information about it. So remember, earlier I showed you that it's a good practice to put docstring, just comments inside your functions. So if it is your own function in a script or in the same file, and you have put that docstring and you try this help for your own function, what will be printed out here is that docstring. So in case you share your function with other people and they try it out, they put this help in the name of your function, they will have that piece of text printed. So if you put something informative, it is nice. If you, in your Python environment, if you type help modules, then it will give you a list of modules that are installed and available in your Python environment. The list can be, if you have a lot of like Python modules, it can be a bit messy and a bit hard to read, but this is one way of seeing what modules are already installed and available to you, so you can just import them if you need them for your work. There are a number of things that are possible to do, but are maybe better to avoid. One thing that you sometimes see in people's scripts, in people's codes, is to import things like this. So from X is the name of the module here, import, then there's this asterisk or a star sign. So what this does, it imports all the functions from that library. You might think it's a good idea because everything is there, but it's not for a number of reasons. One main reason is that you don't know what functions are available. There are probably many functions, and they might end up having conflicts with names. As I said, these scripts, these modules are codes written by other people, so their name of the functions they have used, they're not reserved words in Python. So you may not necessarily get an error, but if there's a conflict with something in your work, in your script, then you will have problem. If you import everything, things can get messy, so generally try to avoid that. And if you know already what functions you need, just explicitly, specifically import those functions. This way there's less risk for conflicts. Yeah, so as I said, be careful when you're picking a name, when you're giving a short name to libraries, pick a name that makes sense. So picking something overly short might be tempting, but then again, when you look at your code later, it might be a bit hard to remember what they mean. And there are some good practices regarding importing modules in your work. One thing you should remember, one good practice is to already import the modules that you need already early in your document. So it's a good practice. So sometimes you just start writing your code in the middle of your program, you remember that, I need this module. Then you just start importing it. It works fine, but it's a good practice to already import all the modules you need at the beginning of your script. So this is easy, and also if someone is looking at your code, they know that, okay, these modules are required, so they start, for example, installing them. So yeah, so follow the good coding practices when working with modules. So let's move on to the next part, unless you have some questions from this part. If there are no questions, then we can look at the good coding practice number 4 for this week. Writing our scripts the right way. So today we already talked about the scripts. So scripts are same as the codes you have written so far. So if you want to make them readable, remember to add comments. Inline comments are useful. If you have functions in your script, remember to add docstring to make the function a bit easier to understand if you look at it later on. So this is an example of how you can add inline comments, and this you have done before. The scripts are no exception. Add inline comments to make your life easier later if you use the script again. If you want to make it a bit readable, so this is already okay because you have inline comments, but if you want to make it a bit even more readable, it is advisable to add spaces. So you have these line breaks between different parts. So if you have different parts of your code that do different things, then you can break it into sections by just adding a break line in between. So if you look at this, this is a lot more readable than this one. simply because there are some break lines added in between. I already talked about doc strings. You can just add these blocks of codes wrapped in these three double quotation marks. You can use them anywhere in your code to have a block of text, a block of comment explaining different things. For example, in this case, what is the usage, who is the author of the script, and so on. But specifically, it's useful if you put it inside your functions, then it will be, it can also be accessed via help. Then yeah, there are a bit more advanced topics maybe you can read on your own, but for example, the same method is used for, like, if you want to license your work, if you're publishing your script somewhere. Very often if you import some module from somewhere, there is information about licensing. They are written like this, using these triple quotation marks. And yeah, another good practice, a bit more advanced, but very often when you have a Python file, people want to just run it easily if you share your code with others. And if you do it now, we have been using this Jupyter Notebook environment, which has been easy. But if you want to just run it on your own computer, you have to first open Python and then do it. If you add this one line of code at the beginning of your script, it makes people's life a bit easier if someone else is using your Python script, because the Python will be opened and then the script will be run. So these are some good practices that you can follow in your work if you work with scripts a lot. So are there any questions? If not, yeah. Yeah. The help of the library, or yeah, maybe you can have a look. And remember that if it is your own function that you have imported a script and then you make a change, because you have imported the function once in your work, it may not work. The update may not be reflected in your work. So if you change your script, remember to restart the kernel, the Python kernel. This is a common issue for many. You update your script, you run it again, you don't see the update. Just restart the kernel, it will import a fresh copy of your script. Yeah, so if there are no other questions, let's quickly look at this week's exercise. Exercise 4. So as usual, there is a link here for accepting the GitHub Classroom assignment, and then you will have your own repository you can work with. So one thing we have this week is the feedback form. We are already halfway through the course, and it will be very helpful for us to know what you think about the course, how we can improve things. There's still a few weeks left, so if there's something that is not working, we might be able to try to fix it in the coming weeks. So before you start your exercise, just follow this link and fill out this midterm evaluation form for us. It will be helpful to improve the course. Then you have 3 problems that you will be solving this week related to what we have done today. So you will be first working with functions, very similar to what we have done today. You will define a function that will convert temperatures from Fahrenheit to Celsius. You have seen the equation already before, and here it is again. So you just create this function and do the conversion. That's the first part. Then we have a second part, second exercise. Let's look at that one. So in the second exercise, we will be doing a bit of classification. So we have a number of temperatures. You have a list of temperatures that are available to you. Then you write a function, Python function that does this classification. So if the temperature is within a certain range, then you return a value 0, 1, 2, 3. So you do that. in several steps. One thing that we are trying out this week is an optional part where you can try to redo the same thing using AI, ChatGPT in our case, or if you want to try something else, you can do that as well. So you try to create the same classification code function that you created earlier in this problem with AI. So tell us what prompt you have written, what is the output. There are also some test cells to see if it is working well enough for you. And then it could be the case that what you get from AI, like we saw, may not be the best solution. So you can write another prompt to improve it. Just tell us what is that other prompt you use and how you developed the code. So that's the part of the optional part of the exercise where you can use the AI. And then we have a third problem that combines what you have done in the previous two steps. So in the first step, you created a function that does that conversion. In the second problem, you created another function that does the classification. What you do now, you drop them into a script, like we learned today, and then you import the functions from the script and apply it to the data that is available to you here. So you have a list of temperatures. This is your data, and then you will apply import the functions from the scripts and apply the functions you had created before. You will apply it on this data and see what's the output. Yeah, so that's the exercise for this week. And remember to do the midterm evaluation. I believe it's open already, or is it?
Yeah, it should be open.
Yeah. Okay. So, yeah. See you next week.